Hello world, I'm Mate and I would like to talk about version 0.0.10. As always, the details are in the blog post, this video providing some real-life examples to complement it. Since this is the latest release, we can jump straight into the appropriate version of Dagger. Version 0.0.10 brings a breaking syntactical change to the system in the form of eager operators and their underlying mechanisms and rules, collectively called imping. Imp is a short name which stands for implicit list, which are in turn lists that for some reason doesn't require explicit groupings around them. Until now, the only example of real imps were lists that occupied their entire line. So for example, if I wrote or write 1, 2, 3 and move over right to the end of the line, which always displays the idea that the entire line produced, I will see that it is a list with 3 elements in it. As you can see, the system doesn't require us to put an explicit grouping in the form of parents pair around it. Now the problem with the old syntax, which was already supporting this, was that labels, for example, work the same way as any other operator. So labels tried to bind to their immediate neighbors, which meant, and now I jump into version 0.0.9 for a moment, if I wrote A is 1, 2, 3 and inspected the result, I found that the label was binding to a num with a value of 1, which means that the label was bound to the first element. If I wanted to bind the label to the list instead, of course I had to put explicit grouping around the list, because then the label's next immediate neighbor was the list itself. Now if I go back to version 0.0.10, I will see that the same input results in a different tree, namely that now label binds to a list instead. With the inclusion of eager operators, we could define label as 1, which means that if it can choose between a single element or an implicit list next to it, it will choose the latter. So in this case, label had the option to choose the entire implicit list, and it took the opportunity and ran with it. Of course, if there is only a single element, label will attach to it just as happily. The design is based on the assumption that this is more natural to read and write. The price we pay is that if I want to attach a label to a single element, I need to put explicit grouping around it, but it also reads pretty well because we can see that B is attached to 2. Now eager operators can not just open new implicit lists, but they can close it. So if I write A is 1, 2, B is 3, 4, that will be a list of 2 lists and both are labeled. This is because B closes the implicit list that A opened. There are only 3 eager operators in the system right now: label, eval, and the graphed operator. Hopefully it only means that we just made them even more intuitive to use them as before. In the case of eval, if I write this, eval will bind to this implicit list. And of course, if I want to bind an eval to an individual element, I will need to group it. And for the sake of completeness, this is an example of a graphed operation where I graphed 1 and 2 onto the 2 sides of an addition, which of course evaluates to 3. Grafting is a big topic that needs its own introduction, so I won't go into details right now. This grafting example was looking like this in the old version. Of course, I had to put the list argument of the graphed explicitly. The rule of thumb is that operators that has space around them in the standard notation are the main candidates of eager operators, except the normal function with normal names, like floor, for example. An important aspect to this change is that it didn't affect the simple and flexible Lispy nature of the language. Lists stayed lists, the argument of operators haven't changed, we just extended the idea of imps from the single line to some of the operators too. The most important takeaway though is until you know how to discover the shape of the tree with the help of the info section, you will be safe, as you will be always able to understand how the parser interpreted your input. I guess that's it for now. Thank you for listening and see you in the next video. Bye.